8M7 lesson 13, comparing irrational numbers. Okay, so this is a lesson that is simply going to almost teach you nothing new. It's basically building on lesson 10, 11, 12, last few lessons we've been doing. And the whole idea is you are going to try and figure out which number is greater given different representations of two numbers. You might get a fraction in a square root. You might get a decimal in a repeating decimal. You might get two triangles with different lengths of hypotenuses, and you got to compare those two. So let's go through these examples, and this is your entire problem set for today is going to be comparing different representations of numbers using the skills that we've obtained over the last few lessons. Okay, so our building blocks, again, is what we've learned in the last few lessons. And the whole idea is we're going to get two different numbers. And the whole idea is you're going to convert them into decimals almost every time. You're going to want to convert them into decimals so that we can compare. That's the key to comparison, is that we can always identify the larger of two numbers that are represented as decimals. Now that's what we're going to do. That's always our fallback position, but that's one key. Whoops. That's one key. But the second key, and let's put the second key in green. The second key is that sometimes we can bracket two numbers between different integers. So if we can do this, this is usually easier. This is the easier thing to do. So if we can identify that two numbers that we're comparing are between different sets of integers, we can easily compare them. But this is the tried and true. We can always convert two numbers into decimals and then identify which one's larger. Okay, so let's look at some examples where we do the easier thing. Okay, so let's look at this easier one. We ask, which is larger, 12/7 or the square root of 6? Well, we could try and use our strategies to to turn these into decimals, which is going to be harder to take 12/7 and turn it into a decimal, because we have to. This is going to require long division to get decimal, and this one's going to kind of do our iterative calculations. Remember when we say, well, it's between 2 and 3, then it's between 2.2 and 2.3, then it's between 2.21 and 2.22 or whatever. That's our iterative calculation. But in this case, we don't need to do any of this, because we can say what? We can say, well, 12/7, well, this is between 1 and 2. And if you don't know how to do that, well, this is the same thing. Let's just look. That's the same thing as 1 and 5/7. And if you don't know how to do that, you can look back in some of the prior lessons. But so this is between 1 and 2. And the square root of 6, we know the square root of 6 is between 2 and 3, because we got the square root of 4 and the square root of 9 that bracket our square root of 6. And that's 2 and that's 3. So the square root of 6 is between 2 and 3. So 12/7 is between 1 and 2. The square root of 6 is between 2 and 3. So the square root, so our answer, our final answer is that the square root of 6 is greater than 12/7. And that's what I mean by the easier solution. Bracketing our numbers between different sets of integers. And I know that on a number line, that if I drew a number line, 0, 1, 2, 3, 1, 2, 3, that 12/7 is somewhere in here between 1 and 2, and the square root of 6 is somewhere between 2 and 3. So 12/7 is less than the square root of 6. Okay, so again, we're going to look for the easier thing, but then sometimes we got to go to this harder thing. All right, let's go to lesson number 2. Now we need to compare the cube root of 27 and 10/3, which is greater. Well, we can do the hard thing or we can do the easy thing. Well, we know that the cube root of 27 is 3, right? Because 3 times 3 times 3 equals 27. So the cube root of 27 is 3. And we know that 10/3 is 3 1/3. So this is greater than 3. So we know that 10/3, because it's greater than 3, is greater than the cube root of 27. So these are our easier types of problems, right? We have two different representations. We have like a radical or a cube root, or square root, and then we have this other thing that's a fraction. And we can't compare them directly, but once we kind of bracket them between two integers or as exactly an integer, we know that we can compare those two things. Now, these next examples aren't so easy. Well, maybe they are. Let's look. What strategy are we going to use here? I want you to try this one using the strategy we learned. Okay. All right. So I assume you've paused and tried. So pause and try. And now I assume you're back. Now we know that this is 3. We know that 9/4 is the same thing as 2 1/4. And we know that the square root of 10, well, what's the square root of 10? What integers is it between? Well, I know that the square root of 10 is between which perfect squares? Well, 16 and 9. So 3. So the square root of 10 is bigger than 3, but less than 4. So I know that the square root of 10 is greater than 3. And again, this is a building block. We learned how to do this thing in, I think it was lesson 11. Maybe it was lesson 12. But it was, this is a building block. So this, don't say, wait, how did you do all this, Mr. Lipscomb? Well, we learned how to do this already. So we know the square root of 10 is greater than 3. Well, 3 is just 3, and 9/4 is less than 3 because it's 2 and change. So we can write 9/4 is less than 3 is less than the square root of 10. That's the order in value of these 3 numbers. Again, you can't look at, it's really hard to look at these 3 numbers and compare them because they're in different representations. But I used my bracketing technology to see that, or skills, my bracketing skills to see that this was between 3 and 4, this is between 2 and 3, and this is exactly 3. So that's how I came up with this order. And that's my bracketing strategy. Now, the next one, I think we finally get to a more complicated strategy. Right. So here, let's look at let's see if we can use our skill here. Well, this is 2 1/4. And square root of 5 is between, well, the square root of 4 is less than the square root of 5, is less than the square root of 9. So I know that 2 is, the square root of 5 is between 2 and 3. Well, 2 1/4 is between 2 and 3. So I don't know. My bracketing, my integer bracketing strategy doesn't work, doesn't help. It doesn't, it's not that it doesn't work, it doesn't help here. So now I need to go one step further, and now we're going to use, this is our first point, and our second point is going to be, we need to convert to decimals. Well, let's try and convert my square root of 5 into a decimal. Let's see what happens. Well, the square root of 5 is between 2 and 3. Now I need to use my skill to see, well, is that between, now is that between, let's see, is it greater than 2.5? Because remember, what we're gonna do is we're gonna try and find which two numbers squared will give me a 5. So I know that 2 gives me a 4, 2.0 squared gives me a 4, and 3.0 squared gives me a 9. So I need to find out what number squared is going to give me a 5. So let's see. Well, let's see what 2.5 does. Well, 2.5 squared, again, this strategy that we're going to use to approximate the square root of 5, we learned how to do, I think, in less than 11. Maybe it was less than 12. So that's 6.25. So the square root of 5 is less than 2.5. So let's try 2.4. Well, 2.4 squared is 5.76. Still more. So let's try 2.3. Well, 2.3 squared is 5.29. And 2.2 squared is 4.85. 2.2 squared 4.85. 4.84. So there's my bracket. 2.3 is too big and 2.2 is too small. So I know I'm between 2.2 and 2.3. So let's write that down here. 2.2 gives me 4.84 and 2.3 gives me 5.29. So let's see what happens if I do 2.25. Well, 2.25 squared is 5.00625. So let's try 2.24 squared. I'm just typing all this in on the calculator. I'm not doing these calculations by hand. 5.0176. So let's try 2.23 and see what happens. Oh, 2.23 is 4.9729. So I know that the square root of 5 is between 2.23 and 2.24. So let's just write that down and see if that's good enough. So 2.23 is less than the square root of 5 is less than 2.24. And again, how we do that is this iteration strategy that we use, and we learned how to do in an earlier lesson. So let's see if that's going to be good enough over here. Well, to do our comparison. Well, 2.24 is the same as 2 1/4. So 2 1/4, so that's equal to 2 plus a fourth. So let's equal, what is a fourth equal to? Well, some of us have that memorized, but if we don't have it memorized, we can just use long division. And we get 0.25. So 2 plus 2 1/4. So, sorry, 2 plus a fourth, and we get 2.25. So 9/4 equals exactly 2.25. Well, 2.25 is bigger than 2.24 or 2.23. So 9/4 is greater than, it's greater than 5. So 9/4 is greater than the square root of 5. Because 2.25, so because the square root of 5 is less than 2.24, and the 2.24 is less than 2.25. So if I put these on a number line, another way to look at this is if I put this on a number line, which we can do now, this would be 2, and then we call this 2.23, 2.24, and 2.25. This is 9/4 right here, and this would be the square root of 5, would be between 2.24 and 2.23. So 9/4 is bigger than the square root of 5. All right, let's do one more. Again, you should be able to do all of these yourself. And again, this is already represented, already a decimal. So this is nice because we can compare this. You know, you can also look at it as 0.222222222 ... And so if we have to compare this to 3/11, let's see what happens. Well, 3/11, let's do long division. We have that other strategy that we learned about in lesson, I forget, 11 or 12, where we could not use long division. But long division is by far the easiest way to turn a fraction into a decimal in my mind. So let's see what happens. All right, 77, 32, 2011 is right, and we're duplicating this number here. So I think we should, and then we duplicated this. That number is duplicated. That number is duplicated. So we know we have a repeating pattern. So this is 0.272727. So we get 0.27 with a bar. Now, 0.27 as a bar can be written as 0.272727. So which number is greater? This is 0.2 bar, and this is 3/11. Well, they're the same here. They're the same here, but here they're different. And this one is bigger because there's a 7. This has a 2, and this has a 7. So 3/11. This one is bigger. So 3/11 is greater than 0.2 with a bar. And again, the building blocks are what? The building blocks are converting numbers into decimals, in this case using long division. And the second thing is the second building block is comparing decimals. Well, the way you compare decimals is you just look from left to right and you compare numbers until they're different. And when they're different, you just pick the number that's bigger. Because this one has 7 100ths and this one only has 2 100ths in the hundredths column. Let's keep going. And this is our last slide. And there's a problem like this one on the homework. So which triangle has the longer hypotenuse? So here our building block is, calculating the hypotenuse. And remember, you have to take leg squared plus leg squared equals the hypotenuse squared. For those of you who don't remember your Pythagorean theorem. So here we're going to find c squared by doing a squared plus b squared equals c squared. And remember, your legs are a and b. It doesn't matter which is which. So 3 squared plus 4 squared equals c squared. So 9 plus 16 equals c squared. 25 equals c squared. So c equals 5. Over here, I get a squared plus b squared equals c squared. And so I get 1 squared plus 5 squared equals c squared. So 1 plus 25 equals c squared. Square root of 26 equals c squared. Well, square root of 26 is between what two numbers? 5 is less than, the square root of 26 is less than 6. So in this case, my hypotenuse is bigger than 5. So this triangle, the square root of 26, and this one, the hypotenuse is 5. So triangle B, whoops, is longer hypotenuse. Because the square root of 26 is greater than 5. Okay, this was not a lesson that I did a lot of, I didn't do really a lot of teaching on. I really gave you just more a list of examples. Because this is, again, building blocks. The prior lessons just had you converting numbers into decimals or converting numbers into various formats. And this is just that same type of problem, but asked differently. In this case, it said compare two numbers. So the way that we often compare them is see if we can first bracket them between different sets of integers. And if we can do that and these numbers are between different sets of integers, then we know we can easily identify which one's greater. However, if the two numbers that we calculate are bracketed or live between the same two integers, then we have to go ahead and convert them into decimals or decimal approximations to perform our comparisons. So we will see you next week, or next day, or tomorrow, or whenever, with 8M7 lesson 14, and we'll be talking about the irrational number pi.